Hey guys, Ken with Behind the Wall Pinball here, and I want to start off with an apology for not posting in a while. I was on an overseas trip for a few weeks, and the only thing that I had to work with was literally my Fusion 360 model for my playfield. Specifically the inserts, which is the subject of this video. Most of this work was done during jet lagged hours between 3 a.m. and 7 to 8 a.m. while the wife was still asleep, so there was no ability to make videos or noise in that tiny apartment, and that drove a significant amount of rework, should I say, when I got back, that I didn't even have the chance to think about hitting the record button. But leading up to that is the important part. Like I said, inserts. We're also going to talk about a little bit about CNC in this video, and you'll see why in a bit. So, before my trip, my design had, let's see if I can get them in here, 5 different shapes and sizes, all clear inserts. So, before my trip, I was on a blitz mission to capture all of the critical measurements from Whitewood number 2, along with getting these inserts dialed in. And I did that, and I learned a lot about that I'm going to try to share. Yeah, that was crazy. But we can see here, if I turn this around, so these were all of my initial settings. And what I needed to do is get these inserts, so take this 1-inch square and get them to press fit so that they don't take too much effort to go in. They go in nice and flush. Things like that. Got there. I thought, yay, cool. Now I have sketch files that I can use to design the rest, right? Wrong. So, in the middle of my trip, I made a decision to switch shape, sizes, and color code my entire playfield. So anything animals related becomes green. So the player knows, they look down, if they see a green light, it's got to be related to animals. Anything related to Division Bell, it's going to be blue. Wish you were here, purple, etc., etc. Right before I left, I think 2 to 3 days before I left Korea, placed a PBL order for all of these new inserts. So it would be sitting on the porch the night that I got back. It was, thank you, Terry and Margaret. And I went to put them in this test board, they didn't fit. So, important thing to learn about inserts. Everything is made in batches and lots. It's almost impossible to see on the camera, but there's a stamp on the top of this. It says 9. So there's no way that this red arrow came from the same batch because it's a different color of plastic. It had to have different colors inserted to it. So this one says 1. So nominally they're sold as 1.5-inch arrows, but I can assure you they are not exactly the same. And this is where the importance of understanding 0.01 inches comes into play. It's going to make a significant difference. So let's talk about 2 different things here. One, I'm going to jump subjects real quick to CNC. All right. So this is my CNC machine. His name is Gerald. 99% of you, if you're building a pinball machine, are going to have CNC in your life. You can do it by hand with templates and routers and drills and saws. God bless your heart if you do that. You're probably going to want a CNC machine, which means you have 3 options. If you're lucky enough to live close enough, you might have a maker space near you where you can pay monthly dues. Set up your cam work, go down there, cut your stuff, set it up, cut your stuff, clean it up, drive the wood back home. No, not too bad. It's probably a one-day endeavor. I don't know what the dues are. I remember I looked at mine here in Tampa. Closest one was, I think, 45 minutes away, and I remember the prices were just not something I was willing to pay. Option 2, know somebody with CNC capabilities, preferably in the pinball space, so they understand the tolerances we're dealing with, anything like that. The problem with that is then you have to get all your materials, you have to ship it to them, wait for them to do the work, wait for them to ship it back. So iteration is not a quick thing. Or option 3, you own your own CNC machine, which honestly, CNC machines are fucking expensive. So I have fairly standard size play field. My play fields run 20 1/4 by 45 inches. So not a wide body, but standard. And that fits within 2 feet by 4 feet. A CNC commercial system that can handle 2 feet by 4 feet is, I think when I looked last, it's going to be well north of $2,000 to $3,000. Not an option. But alas, there is a solution if you're willing to put in the work. So there's a company out there called V1 Engineering, and they make a system called MPCNC, mostly printed CNC. But it's going to cost you work. But if you go to Google and just, it's already there, MPCNC, you're going to get to V1's homepage. Let's see if I can get this tripod a little bit closer for this part. Now, if you go to MPCNC, you're going to open up straight to their normal platform, which is a smaller system that is not capable of playfield work. But you have an option up top called Lowrider, which is a full gantry style CNC machine. And the whole concept is you print everything on your 3D printer and you use their kit to build it. And the only things you need to have is a small spindle, which they have an option to purchase, and you need to buy conduit. I think that's a little bit of quarter inch wood. Yeah, for the struts. Not a whole lot. And that'll actually be one of the first things you cut with it, because you print temporary struts to begin with. So check this out. I will show you in a minute. You can get out the door with a CNC machine for under $500. It can be more, depending what you need to add to the list. So if we go here, somewhere on here, we actually have V1 Shop, and we can come here, skip this because I don't know why it skipped straight to that, but we can go to Categorized under Shop, Lowrider Parts. We can see the kit itself is $338. Now that's going to include all of your stepper motors, your XZ plates, it's going to include wire harnesses, hardware, all kinds of crap, almost everything you need. The only thing you need to add to it is the actual physical controller for it, which is only $76. So if we take $338 plus $76, we've got a CNC machine for $414. And then the only thing you have to add to it really is the conduit, and you can design it any size you want. Mine is specifically designed for 2 foot by 4 foot, because that's all I need for a play field. And my bench I built years ago is 3 foot by 6 foot, so works out perfectly. So why all this CNC talk? Every CNC machine is going to have its own unique characteristics. So I have learned in this process, specifically through the initial insert cuts, that my designs have to have 0.05 inches added to them to be accurate. And it's been almost universal. Get a commercial, maybe yours is 0.00, I don't know. Mine specifically is 0.05, right? So we go back to inserts. Where's Fusion? So I started all of my inserts on what I called an insert test board model. For a 1-inch square, I made a 1-inch square with ledges. Lessons learned there too, that I'll show you in a second. But the insert didn't fit when it cut. So we iterated and iterated and iterated. You can do this by hand, or there are web resources available. Not that I planned this or anything, but there's a site called, let's try to get this closer again, Pinball Makers. It has a wiki site, and if you search Pinball Makers files, you're going to come to this site that has so much 3D stuff and modeling stuff that you don't even know what to do with it, and that includes some standard inserts. Take note, they are .dwg files, which are not compatible with Fusion. We'll get into that in a minute. Another resource you have, something I learned in the last week, Mission Pinball Framework, that most of us are using, has an open source pinball hardware CAD models page. And they have so many CAD models to include types of drawing files and assemblies and all kinds of stuff. If you want spinners, they're in there, from stern to ballies, ball launch, everything is in here. It's amazing. There's also an Adobe Illustrator file out there in the pinball world called Pinball Design Library. I can share it if you want. And it has just so many different CAD designs that you can export as your own drawing files. Or I think you can do DXFs. I actually have not used this much, but within it is a jewel library. God damn it, I keep going the wrong way. And hopefully you can see this. But there's so many different types of inserts that you can export. So, great, right? You can have all of these exported drawing files and blah, 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 but you can't use them in Fusion. But there's a free web service called Cloud Convert. And you can download or convert almost any type of file you want to a DXF, which is useful. DXF is what you want for your sketches within Fusion. Now, if we go back to Pinball Makers, I mentioned assemblies. And you'll notice most of these assemblies are SolidWorks files. Whether you want GI lighting, drop targets, there's pop bumper assemblies, rollovers, and most of these will actually go right back to what you guys are ordering from PBL and Marco. You want star post, they're all in there. I'd recommend you just make your own inserts, lane guides, spinners, ball gates, flipper assemblies. It's all in there. So check that out. Pinball Makers files is all you need. But if you download the SolidWorks files, you obviously cannot open those in Fusion. But if you have SolidWorks, you just get a temporary subscription. I think there's a free subscription too. What you can do is bring those in. So if I go back to my 3D files and Pinball Makers, I've got all of these SolidWorks files. So you either have an SLD PRT, which is a part, or you have an SLD ASM, which is a full assembly. So it'll be all of the parts of that assembly. You can open that up in SolidWorks. Oh boy, oh boy, oh boy. Where's my desktop? There we go. Pinball, Pink Floyd pinball, 3D files, pinball makers, and we can just go trough, WPC trough, and then we can find that assembly. Da-da-da, and it opens the whole thing. And what we can do with the trough after that is then export it as a step file. So a .step file, which is then fully usable within Fusion. So let's say I go over here and I want to open, because I've already done that obviously. So Pink Floyd pinball, 3D files, step files. So we were just looking at that trough assembly. So WPC trough step. Boom, the whole trough opens up and we can edit absolutely everything. So anyway, that was a little bit of a sidebar from inserts. So let's get back to inserts. So we talked about where you can get insert files from. The other option is, once you know your machine, you could just make them yourself, really. So if I go back into Fusion, let's take our 1-inch square again as an example. And let's say I want to make an insert for a 1-inch square. I can come in here, and we want to do this in a completely isolated file. If you do this, if you try to make this on the playfield itself, it's going to start linking to everything else, and then when you come back to it, you're going to be in edit hell, I promise you. So your best bet is to make a master sketch for every single insert, whether you download it or make it yourself, export it as a down or a standalone DXF file. So now you have, I've got a 0.75 inch circle, 0.75 inch square, 1 inch circle, 1.5 inch rectangle. I've got them all. Hopefully you guys get to do the same thing. But here's how easy it is. So we want to make this square as a master sketch. So we create a sketch, pick the right plane. I always like to work in centered things because that's probably my OCD. Now, I think I mentioned earlier, Gerald, my CNC, needs a 0.05 inches added to all my dimension. This is just something I learned. So my square is going to be 1.05 times 1.05, enter. Okay, so now we have finished sketch over here. We do not want to click finish sketch. And the reason being, because when we bring these into the model itself, we want the entire insert cut to come in as one finished item. So we need another sketch within this to define the ledges. I would love your feedback on this. I'm currently using 1/8 inch ledges, probably a little too wide, but the narrower ones, I find that Gerald does not cut accurately enough, that I need slightly larger ledges on my CNC machine. So what we can do to make those ledges is make another square. I'm not saying this is the right way. This is one way, and not the most accurate, is now I can come back in here, make another square that is a 1/4 inch less, because that'll give us 1/8 inch ledges on the other side. So we're going to go 0.8 by 0.8. Boom. Now I have another square. Inside that square, I can measure, and the distance between the two is 1/8 of an inch, 0.125. Right? Before we close this sketch, there's one other thing that I've learned that's kind of important. Every single one of these inserts that has rounded corners, they're all going to have rounded corners if they're not circles, right? Usually that fillet, so the curve, is going to be 1/8 of an inch. I'm not saying that's a guarantee on all of them, but everything that I've touched thus far has been 1/8 of an inch. So I consider it almost universal. So we can go in here and do not that. Go back to this. I don't know where the hell my sketch went. I can do it right here, I guess. Okay, screw, oh, there it is. Oh, we're under sketch. So I can hit the fillet button. It tells me select two sides. 0.125. We can do this for all 8 corners. So we'll just act like we did what we needed to do. Let's go ahead and finish this sketch. We'll just pretend that all 8. What I highly recommend, rename it. So this will be 1 inch square master sketch. I'm not going to save it, I already saved it, but then we can come into our model, select the plane that we want, so the top of the play field, go to Insert, DXF, select DXF from my computer, 3D files, DXF, and I've got a 1 inch square. And now what I get is a fully controllable, independent sketch that I can then extrude. And like I said, I like to make my ledges minus 0.272 is what seems to work good with Gerald. Anyway, I think there's probably more lessons learned. I also found that there is another thread on pin side. I did save it. So check this out if you want to, called Vid's Guide to Playfield Restoration. And this guy has everything you need to know about inserts, from scuffing them down to 100 grit, putting primer on them, how to properly apply your epoxy when inserting them. Damn near everything you need to know. This is something you probably want in your toolkit. But with that knocked out of the way, I just wanted to get that caught up. Insert hell. I didn't cover offsets. I think I might have kind of covered offsets. Maybe not. Or we can get into that later about how we adjust them. So I mentioned that I came back and my inserts were all a little bit off because these guys, the colored ones, were bigger. Very easy to go back into your model. I just wish there was a more universal way, which I'm sure there is. But let's say I take the B, roll over from bike. Oh, where's my first 0.75? I can come in here, already done it, but I can select edit sketch, select this outside contour, hit O, and I can then make it bigger if I want and re-extrude. Probably the cleanest way I found to do it, but I'm sure there's a way it can be linked to where I can go back to the master sketch, edit it, and it applies it across the playfield. That would be nice. But I'm kind of new to Fusion. Not super new, but I'm not an expert by any means. Anyway, hopefully you stayed this long and watched. We're going to get ready to do one more test for Whitewood 3, and that is because my cam process, so manufacturing, getting ready for CNC. I've already exported my G codes. I'm testing 2 different plunge rates on drill ops because I've never done a 1/8 inch drill op on these, and I had an engineer buddy tell me last night he thought my plunge rate was a little too aggressive. I'm going to test them on the insert test board and see if I snap a router bit. It doesn't add much extra time to slow it down, so we'll just see what I'm happy with on those first 2 operations. It's about 2 minutes of work each. Then I think we might cut Whitewood number 3 today. We'll see. I'm going to try to take some video of that. It's probably going to be multiple videos stitched together and then a giant time lapse in the middle. So my operation is currently 3 hours and 8 minutes and 3 seconds. It's going to be a significant chunk of change just sitting here babysitting the CNC machine. So anyway, let me know if you guys have any questions, feedback, something I should do different. Like I said, I learned more about CNC not CNC, but Fusion 360 every single time I'm in it. It's not the scariest thing, but it's really easy to break and fuck up. Until then, I'll see you guys on Whitewood number 3. So, have a good one.